After centuries of exploring the Arctic from the ground, sea, and then by air, a revolution was about to take place thanks to our new view from orbit. With the space age in full bloom, the first satellites to take regular images of Arctic sea ice were Tyros weather satellites.
The most complete collection of instruments ever assembled to study the use of space vehicles for comprehensive weather observation. The most important of these being two Vidicon cameras. Both record on this magnetic tape machine, and on command send their scannings back to Earth.
But the Tyros instruments could not see through clouds or during the long polar night of winter. Starting in 1967, NASA began testing more advanced satellite instruments on board research aircraft over the Arctic. In 1972, a new satellite called Nimbus 5 and its ESMER instrument began 4 years of all-weather, all-season imagery of sea ice. And in 1978, Nimbus 7 used its more advanced microwave instrument, which could for the first time help distinguish young ice from old. In 1983, the first Atlas of Antarctic Sea Ice was published by NASA Goddard researchers, followed by an Arctic Atlas 4 years later. Both were used by scientists and mariners around the globe. In the first few years of continuous data collection, researchers started to see a slight decline in the ice, but they reported the decrease was still within the realm of yearly variability and not strong enough to tie decisively to a changing climate. But in 1999, the trend was becoming clear. The Arctic was losing ice cover at almost 3% per decade. In 2002, NASA launched the Aqua satellite with Japan's AMSR-E instrument, which provided even more enhanced observations of ice extent. And in 2003, NASA launched IceSat, which had a laser altimeter on board that provided data for producing maps of ice thickness. New record summer minimums were reached in 1999, 2002, and 2005. But in 2007, a shockingly large decline stunned the research community, and scientists realized they needed to get a better handle on not just the surface area of the ice pack, but its thickness as well. New missions started to focus on sea ice thickness data, including an ongoing NASA airborne campaign called Operation Icebridge and the European Space Agency's Cryosat-2 satellite. In summer 2012, due in part to even thinner ice and a strong Arctic cyclone, yet another record minimum was reached. The last few years haven't set any new records, but ice extent and volume continue to be well below the levels scientists first saw when the satellite era began. Computer models predict Arctic sea ice will continue to shrink in coming years. With new satellite missions, instruments in the air, and boots on the ground, researchers will continue to study not only ice cover and thickness, but also how the loss of ice will affect both the Arctic and weather and climate patterns.